Now we're going to put everything together to solve equations so that we can find linear relationships even when they don't look like a form that's familiar to us. So we've been working with y equals mx plus b, and when it's in that form, we can easily tell what the slope is and what the y-intercept is. But here we have an equation, 2x plus y equals 3x minus 7. And even though that is a linear relationship, it's not that easy to tell what the growth factor is or what the y-intercept is. So we want to rewrite this equation in a form where we can figure that out. So I would prefer that this say y equals something times x plus or minus a constant. So what we're going to do is we're going to solve for y. So instead of solving for x, what we want to do is isolate y on one side of the equal sign and everything else on the other side of the equal sign. So let's start by writing this out. So 2x plus y equals 3x plus 7. So first thing we want to do is isolate the variable. I want this to be in terms of y, so I need to move this to the other side. So I'm going to subtract it from here, which means I also need to subtract it from the other side of the equal sign. So what I'm left with is y equals x plus 7. So now I can look at this and see that the slope of this line is 1 and that the y-intercept is 7. Not so easy to see from this form. Let's look at one that's a little more complicated that will incorporate some of the work that we did with the generic rectangles and the distributive property. So when we look at problem E, I notice that I've got these parentheses in here that I need to deal with first. If I were building this with algebra tiles, I would need to have 3 x's and 3 1's. So what I've done is I've multiplied 3 times everything inside. So when I rewrite that, I have 5 minus 3x minus 3 on one side. So this little section here would be one generic rectangle, but I would still need to put it back into the equation once I've figured out the sum for that. And that equals 2y minus 3x plus 2. So now what I want to do is isolate y on one side and move everything else to the other. So we're going to add 3x and we're going to subtract 2 from both sides. So we're adding 3x and we're subtracting 2. So what we're left with, this becomes 0. So I have 5 minus 5, which is also 0, equals 2y, which means so we know that y has to be 0 in order for this to be true. So we can plug that, we wouldn't plug that back in. We would need a second equation in order to do that. My bad. Okay, so there you go. Using the distributive property to rewrite expressions in an expression that makes sense, y equals mx plus b.